We will start these notes on part 2 of section 5.5 with a quick recap of the previous lesson where we were looking at a binomial situation and determining whether we could use the normal approximation on it. So pause the video, read the situation, and identify the NP and Q, find NP and NQ, and determine if we can use the normal distribution and answer the following questions. Then start the video to check your answers. Alright, in this situation, a survey of U.S. adults found that 76% would pay more for an environmentally friendly product. So we randomly select 20 adults and ask them if they would pay more for an environmentally friendly product. So N is 20. P, we're asking for more environmentally product, and 76% said they would. So P is 76. Then Q will be 1 minus 0.76, so Q is 0.24. In part B, find the products NP and NQ. Well, NP is 20 times 0.76, that equals 15.2, and NQ is 20 times 0.24. That equals 4.8. Alright, so determine whether we can use the normal distribution. Well, NP and NQ need to both be greater than or equal to 5, and NQ is not. So this is not approximately normal because NQ is less than 5. So this means in part C, finding the mean and the standard deviation is not appropriate. And part D, we couldn't find probabilities with this situation, again, because it is not appropriate to use the normal distribution in this situation. Just a quick practice on D, though, in the case that we would be able to find the problem. The probability statement with the continuity correction for the probability that at least 12 people, well, that would be the probability that x is greater than or equal to 12. Right? The continuity correction on that, looking at greater than or equal to 12, that would be the probability that x is greater than 11.5. Right? Again, it doesn't make sense to find the probability because this is not approximately normal, but that's just extra practice with the continuity correction. Alright, so yesterday we looked at whether or not we can use the normal approximation when dealing with a binomial probability problem, and we started to identify the mean and the standard deviation, and we worked on continuity correction. So today we're going to take that last step and actually calculate probabilities with a normal approximation. So if we look at the steps involved, the first step is verify that the binomial distribution applies. So we use we read the problem and identify N, P, and Q, just like we've been doing. Step 2 is to determine if you can use the normal distribution. This is another step we've been doing. We just verified that N times P and N times Q are both greater than or equal to 5. Then, in order to use the normal distribution, we need to have a mean and a standard deviation. So we use our binomial probability formulas to find the mean and the standard deviation. And step 4, we write the probability statement using the continuity correction. Right, and we've already done that. So step 5 is the new thing. All right, after this, we just find the probability. Okay. And step 5 is telling us to find the z-score, and step 6 is telling us to find the probability using the standard normal table. Of course, we can simplify both of these steps into one just by using the calculator. Right? At this point, we will have the mean, we will have the standard deviation, and we will have our probability statement from step 4. That's everything we need to use the normal probability distribution function on the calculator. All right, so going on to the next slide, we will take a look at some examples of finding probabilities. All right, so in the first example, a survey of U.S. adults ages 18 to 24 found that 37% get no news on an average day. All right, so you randomly select 200 adults ages 18 to 24 and ask them if they get news on an average day. All right, now, if we go down to the probability problems in A through C, all of them are asking that they do not get news, right? The probability that they get no news. So success is someone responding that they get no news. So we want the probability 0.34 that they get no news on an average day. All right, we're randomly selecting 200 people. So before we answer any of the probability questions, we just have to verify that this is approximately normal. So NP would be 200 times 0.34. That equals 68. And NQ is 200 times times 0.66. Right? And that will be 132. So this is going to be approximately normal. We don't have to worry about that. We do need the mean, which is 68. So the mean is 68. And the standard deviation is going to be the square root of n times p times q, which will come out to, let's see here, 6.7. Right. So now we have the two key informations, the mean and the standard deviation. We can go on to parts A, B, and C. So A is find the probability that at least 85 people say they get no news on an average day. So we want the probability that X is greater than or equal to 85. So we need to do our continuity correction. This will be the probability that X is strictly greater than 84.5. So we can use the calculator. We want the normal CDF, right? Because we want greater than 84.5, we have 84.5, comma 10,000, comma the mean, which is 68, comma the standard deviation, which is 6.7. All right, so go to your calculator and enter that in. And we see that this probability is 0.0069. Alright, so pretty small probability that at least 85 people say they get no news on an average day, because our mean is 68. Right, so part B, we're finding the probability that fewer than 66 people say they get no news on an average day. So we want the probability that X is strictly less than 66. Right, using our continuity correction here, we have the probability that X is less than 65.5. So using the calculator function, we want normal CDF negative 10,000, 65.5. Our mean, again, is 68, and our standard deviation is 67. So we can enter this into the calculator now, and we have 0.3545. And finally, in part C, we want the probability that exactly 68 people. All right. Now, in the normal approximation, whenever we're looking at exactly 68, or exactly any number, we have to subtract a half and add a half. So this will be the probability that x is between 67.5 and 68.5. So we want the normal CF 67.5 comma 68.5 comma our mean, which is 68, comma standard deviation, which is 6.7. And again, going to the calculator, we end up with 0.0595. Right, so 5% chance that exactly 68 people say they get no news on an average day. Right? And that may seem a little low because that's the mean, but if you think about asking 200 people, just getting exactly the mean, right, that's probably not likely to happen. Right? You expect to get around the mean, but getting exactly the mean, it's not going to happen every single time. Right? It's about a 6% chance of that happening. So now go on to the back and work on the practice problems, and then check the second video to see the answers.